A student throws a set of keys vertically upward to her sorority sister, who is at a window at 4 meters above. The keys are caught 1.5 seconds later by the sister's outstretched arm. With what initial velocity were the keys thrown? I encourage you guys to pause this video and to give this problem a shot. For assuming you pause this video and give this problem a shot. Alright, let's all. Alright, so here's the scenario. The first step to start fix this problem is to visualize. The second step is to conceptualize and then use the math as a tool, and then the last step is to solve them or to check your answer or whatever. I don't know. I wasn't really making any sense anyways. So a student throws a set of keys vertically upward. So this keys is going to go up, or this object is going to go up. I'm not sure if it's going to go up. I mean, it's definitely going to reach higher if she doesn't catch it, but it's going to go up and then it's going to come back down. So that's all you need to visualize. Think about the motion here that we're going to set up. In fact, let's do that right now. This is going to be the t-axis, and this is going to be the x-axis or the y-axis. And I'm going to set up the motion as the output divided by the time is going to look like this if she doesn't catch it. So notice that it's going to be 0 at some initial output, and then it's going to be 0. And that's it, folks. It's I'm not sure if she's going to catch it when it's going down or she's going to catch it right when it goes up. But it does give the specific time. And because we have a specific time, we can actually figure that out. So the y-put, this being x, or I mean t and y, is going to be some initial height, or no, 0. So we're going to call this 0. And she throws the keys at some velocity. So in other words, whatever, some initial velocity times the time. And gravity, of course, is going to be downward. And she's going to catch it at 1.4 seconds later. So so this is going to be the velocity times the time minus g over 2t squared. And now we're going to let t, and let's actually call the h the height, and the height here is going to be 4 meters above. So let's find the time it takes. It could either be here. It's probably could be here from what I remember for the height and that specific time. So let's let y be h. Put the gt over 2t squared divided by t. There you go. Boom. There's your initial velocity. So once you got your setup ready, all right. So we're gonna let the output be 0, 4 meters. And we're going to let the initial velocity be, what is that? That's what we're solving for. T minus 9.8 meters square per sec 2 times t square. So let's put that, let's put 4.9 t square. Oh wait, let's just put g for here just to make it nice. In fact, let's do that. Let's put g. And let's put h. So you have 2h divided by g. Sorry. I'm going to solve for the initial velocity. I'm losing track here. H plus g over 2t squared divided by t. There we go. That's what we're solving for. So h is going to be 4 meters. 4 meters. Plus 4.9 meters per second squared times the 1.5 seconds square, all over 1.5 seconds. So it's really just 4 plus 4.9 times 1.5 square. I'll take that divided by that many seconds, and I end up getting 10.1. I'm not sure if that's right, but let me correct it. Oh, that is correct. Okay, yeah. So that's right. So from there, folks, from part A, the initial velocity is going to be 10 0.0166, or in this case, I'm going to round this up to 2 meters per second. What was the velocity of the key just before they were caught? Well, we just got the initial velocity. So the final velocity is going to be some initial velocity, 10.02 meters per second, minus the acceleration, which is 9.8 meters per second squared, times the time it took to reach at 4 meters, which we solved, which is 1.50 seconds. So it's really taking that v minus g times 1.5. And I know this is going to be the answer. So here you have the final velocity being negative. Notice that it's a negative value here because it implies downward. So this is going to be the final velocity. So the final velocity is going to be downward at negative 6.8 meters per second. So in other words, she throws it up, it's going to bypass the window, and it's going to come back down, and then she's going to stretch her hand and catch it. So that's all.